Hello guys, welcome back to the channel. So in today's video, we're going to go ahead and learn how to build a chatbot, basically that is able to chat with your personal data without that the internet doesn't know about. So let's say that you have a PDF document, right? And you want to chat with the PDF document. So I'm going to go over ahead and I'm going to show you all the techniques of document retrieval, question answering, and different techniques. Basically, in general, we're going to go over and cover a technique known as retrieval augmented generation. So at the end of the day, you're going to go ahead and build a chatbot that can be able to chat with your PDFs or any other data that you have. So let's say that, for example, you are a student and you have a lecture notes, like a PDF document that your lecturer sent you, and you don't have the time to read that PDF document. So basically, you can basically chat with the PDF document. You can upload it and then basically ask the chatbot, for example, give me a summary of what was said in the PDF, and that bot is going to go ahead and give you a summary. So this is going to what you're going to go ahead and cover, and it's a process known as retrieval augmented generation, and can be applied to any type of data that you have that is not publicly available. So let's say that you have some proprietary data in your company, or you have some personal data that you don't that LLMs like ChatGPT, Bird, or Bing don't know about. So if you ask the ChatGPT such questions, it can't really tell you. For example, let's say I have a company that sells cars, right? And I go ahead and ask ChatGPT, hey, how many cars did I sell in my company X, Y, and Z in 2010, or in 2015, or in 2023, right? ChatGPT doesn't know that information, right? Because that information is not publicly available. So how are you able to connect these LLMs, existing LLMs, like the the GPT-3, to be able to chat with your data? And that's what we're going to be covering in this tutorial. So let me just go ahead and give you a quick demo of this project. Okay, so let me just shift Windows right here. So this is basically how the bot is gonna be like. So basically, I have uploaded a document on the book Rich Dad Poor Dad. This is quite a very famous book, so I decided to use it. So Rich Dad Poor Dad. I got the PDF of the book online, and that's the book you're gonna be using. Okay, so this book talks about Rich Dad Poor Dad. If you've never read the book, it's a great book. I advise you to read it. If you want to get some financial literacy, it's just an awesome book. So I have taken this book and I've simply created an LLM based on it. Okay, basically create a chatbot that's going to enable us to chat with this book. So this book is about financing, about finance and how to make money, how the rich don't work for money and all that. Okay, so it's called Rich Dad Poor Dad. You can go ahead and read about it. So let me just go back into our bot right here and let me just ask it, okay, what is the book about? So let me just ask it okay, what is the book about? And then press that. So you can see I simply asked our chatbot, what is the book about? So our chatbot has this book in memory and it's going to go ahead and read through and it's going to answer our question what the book is about. So I mentioned the book is about financial, right? So you can even tell us the name of the book. So the main focus of the book, Rich Dad's Advice. So I think it got the name there wrong. So the book is really called Rich Dad Poor Dad and not Rich Dad Advice. Okay, but let's just say we got that right. Is to provide genuine and advice on financial literacy and wealth creation based on the teachings of authors Rich Dad, and that's very true. In the book, the author has a rich dad and a poor dad, right? So basically, you can see it's actually giving us summary of what the book was. So if I've never read this book before, I never came across this book, and I can just simply be able to use retrieval augmented generation and build a chatbot on top of it. So this can be any document, not just a PDF file, right? It can be any other book, any other thing that you have, and you can do all this. So you can see that now I've never read the book, but I know that the book's about financial literacy and that the author had two dads. One is a rich dad and the one is a poor dad, and you can go ahead and read through about the whole summary of the book. So basically I can ask it any question, right? Let me just ask it uh, what lessons did what lessons, let me just see what lessons were mentioned in the book. Okay, so let's see what response we got back. So there are a couple of lessons mentioned about in the book, like for example, how the rich do not work for money, money works for the rich. I have read the book a couple of times, so it's really a good book. You can go ahead and read about it. So you can see why teach financial literacy, the rich don't work for money, and all that. Mind your own business. Those are the different techniques. The different lessons given in the book. So overcoming obstacles. Let's see what it responds to. So the book Rich Dad's Advice, the author reflects on the decisions to reject the highly educated father's advice, which is very true, about money, and instead listen to the rich dad, which is very true. The decision shaped the rest of his life, a lot, blah, blah, blah. And you can see all that. The book emphasizes the power of financial education. That's absolutely true. And then money they believe that the knowledge of how money works, individuals can gain power, insights, start creating their own world and all that. Since the author started learning about at a young age, which is very true. The book focuses on 6 main lessons presented in a simple manner to serve guideposts for renders, blah blah. You can see all that. So therefore, the lessons mentioned in Rich Dad's book revolve around financial education. You can see all of that. Okay, so let me just ask you, can you mention for me the lessons? Kindly mention. Okay, so kindly mention the lessons. Uh, okay, kindly mention the lessons. Okay, let me just ask you that because this bot also has memory, so you can also remember what we asked it previously. So as I said, I mentioned the lessons, and let's see what we got back. So basically, I expect to get back things like this: the rich don't work for money, teach financial literacy, and all that. So let me just see. Okay, say the importance of education in building business as a path to financial success rather than solely relying on traditional job security. That's absolutely true. It doesn't give me this, but yeah, you can see. So it can give me information. Okay, it's also about the cash flow quadrant, which is another book written by the author. Okay, Kiyosaki. Okay, so Robert Kiyosaki, I think that's the author. If I'm wrong on this, please can let me know in the comment section below. So that's basically, you can ask you the different question. Okay, I don't want you to waste my time. Let's actually build the app so that you guys can test it out on your own. So basically, I think the best way to ask this is, can you mention the name or the lessons in each chapter? I think that will give me a better result, but I don't want to waste your time. Let's get, you can see now how the bot works. Basically, we are chatting with this book, and which I never read. Let's assume that I never read the book, but I read this book a couple of times. So let's say that I never read the book. Now I can know what the book is about, and I can basically, if I have an exam on the book, I can basically ask questions that I want to, and then basically get feedback from the book, right? So that's basically it. So now let's go ahead and get started with it. So let me just go back in here. So now you have looked at the project demo. So let's look at the things that we'll be covering in this project, in this video. So we're going to look at what is the project, what is RAG. Okay, we'll cover what is RAG means. Development, we'll set up our development environment. You're going to go ahead and look at the different libraries and dependencies that we need to have installed. We also look at how to load documents and split documents. We look at creating embeddings. I also move ahead and look at creating vector stores, creating document retrieval techniques. We'll then move on to question answering techniques used in retrieval augmented generation. Okay, so we'll also look at conversational chain, which handles the conversation ability of the chatbot. We'll look at the Streamlit, which is basically the UI of the application. And then finally, we'll combine the conversational chain with the UI, which is going to be in Streamlit, and then finally we're going to get basically get a chatbot. Okay, so that's basically what you're going to go ahead and cover in this video. Okay, so let's go ahead and see why this project. Why do you have to build this project? Again, let me just use an example. Let's say that you have a company, and your company, you sell vehicles, right? So you might want a chatbot that can give you analysis on that. So for example, if I have a chatbot that handles my company information, I can just go ahead and taking the consideration that I own a car company, I can just go ahead and say, hey, what was the total sales in the month of September, right? And the bot is going to go ahead and give me the total sales in the month of September, right? Basically a chatbot. So I'm basically chatting with a chatbot, and which has access to my proprietary data, and it's going to go ahead and, basing on that data, it's going to give me responses back, right? So I can go ahead and save myself a lot of time, right? So imagine that you are a manager, and you can just go simply ask a chatbot, hey, what are the total sales on this day? What are the most sold products on this day? That's all possible, and that's this project is a stepping stone towards that direction. So that's one reason why you should have such a project, right? So let me just go ahead and say, what are the shortfalls of current LLMs? Okay, so let me just go ahead and use the example of a Tesla Model X example. Okay, so let's say that I'm a user, and I went ahead and built my own LLM, right? I built the LLM in 2023, right? So this LLM has access to all the current information on the internet in 2023 and backwards, right? So basically, I ask it, what's the price? The bot knows what's the price of a Tesla Model X, right? Because that data was available to it at the point of training, right? So it knows the current price of the Tesla Model X in the year 2023. Okay, so I ask it right now, what's the current price of a Tesla Model X? It's going to go ahead and give me the price of the of Tesla Model X based on the year 2023, right? Good. So that's great. Now let's say that then let me just go back in here, go back to this slide. Let's say 10 years down the line, which is going to be in 2033. Okay, I ask my LLM again, what's the current price of the Tesla Model X? Okay, the LLM is going to go ahead and give me the answer based on the knowledge that was made available to it at the point of training in 2023. So it's going to tell me the price of the Tesla in 2023 and not 2033, right? Which is an issue. So how do we solve that issue? So one way is simply train the model very often, right? Train the model every year or some couple of months or after every week. So if the price of the Tesla change today, I need to go ahead and train my model. That's really tedious, and considering that training models can take months and very expensive procedure to do. So training the model often to always have the current data is just a no-go, right? So for example, if you go to ChatGPT and you ask it a very current question, it will answer and say, hey, I don't know the answer to this. I only have information, I think, from 2021 going backward in time, right? It doesn't have the information from that time going forward. So it doesn't know any of those informations. So one way to solve it is currently going ahead and training the GPT model again to have current 2023 information. And that's really expensive, takes a lot of time and resources. Another solution to this can be, hey, why don't you just connect the LLM to basically a database that has the current prices of the Tesla? So basically, when I ask the LLM, what's the current price of the Tesla, it's not going to go ahead and give me the information that it was trained on in 2023. Instead, it's going to go ahead and query a database and then get the latest information and return it back to me. That would be a better approach, right? Yeah, kind of better approach than training the model all the time. So that's one way you can do it. Okay, so maybe in the future there'll be other different techniques, but for now, this is what I thought about. And in truth, we can do that with LLMs. Basically, we connect our LLM to a database. When I go ahead and ask my LLM in 2033, what's the current price of a Tesla Model X? It's not going to go ahead and give me the current price of a Tesla Model X in 2023. No, it's going to go ahead and retrieve the current price of a Tesla Model X from a database that has the current Tesla Model X price. So it's going to go ahead and retrieve the information. And once it has that information, it's going to use its generative ability, basically its ability to understand human languages and also be able to respond to humans in a very nice way, right? A generative way, basically in a kind of like having a conversation with a human, right? So it's going to go ahead and get the current price of the Tesla and then use its generative capabilities to be able to respond to the user's question, right? So basically it's the same LLM. The only thing that is going to be changing is our database, and that to update a database is quite easy, right? So you just update the database with the latest Tesla price instead of having to train the LLM. That's going to take you a long time and a lot of money. So we are going to go ahead and save a lot of money and also be able to get access to the latest current information, right? So that whole process is what we call retrieval augmented generation, or commonly called RAG. Okay, so retrieval augmented generation, or RAG, is what this process basically is: connecting our LLM to a database, and then be able to retrieve information from the database and use the generative abilities of the LLM to be able to answer the user question. That's the whole point of RAG, retrieval augmented generation. Good. So now that you have looked at RAG on a surface level, how does RAG really work on a deeper level? Because on a surface level, we just have LLM being connected to a database, be able to create a database, get the information, and be able to use the information along with its generative capabilities to be able to respond to the user. That's basically how our chatbot is going to work. But now, how does that work in the background? Okay, so for example, let's take an example of, in our case, we have a PDF document. So let me just go back in here. So we have this PDF document on the book Rich Dad Poor Dad. Okay, so in this document, we have natural text in there, right? These are human natural languages. Computers do not understand human natural languages. So how is my bot being able to query this book and be able to answer information from the book? How does that work? So for example, we take the document, which is going to be my PDF document. What you're going to go ahead and do, you're going to go ahead and break the document into chunks. And why are we breaking the document into chunks? Okay, so looking at the book, my Rich Dad Poor Dad is about almost 300 pages, right? Now that's a lot of text, right? So LLMs have some limitation called context window. So context window basically is the amount of chunk of text that you can feed to the LLM that you can work with at any point in time at one instance. More than that, it's not going to work, right? So if you go to ChatGPT, you can even read the official documentation. They specify a context window of about 4,000 tokens or 4,000 something. Yeah, I think 4,000 tokens, right? Yeah. So you can just feed the LLM with infinite amount of text. What if I have a book or a PDF that has one, maybe 1,000 pages? That's going to be a lot of text, and you can just feed the LLM can work with just 1,000 pages of text in one go. So that's why we split the document into chunks. So we'll be split into 3 pages, 3 pages, 3 pages, 3 pages. So we get the book of 1,000 pages, and then we break it down into three pages, 3 pages, 3 pages as individual documents. That's what we mean by splitting document into chunks. After splitting document into chunks, right, each chunk is going to be a standalone document. So now, again, as I mentioned earlier on, LLMs do not, or computers do not understand natural languages. So what we simply do is that we need to store the natural language in a form that the computer can understand. And that's where the point of embeddings come in. So with embeddings, what we simply do is that we take the natural language, which is the human language, for example, in English, Arabic, Swahili, Spanish, whatever language it is, Chinese, whatever language it is, it simply converts that language, convert the text into a format that the computer can understand. And that's what we call embeddings, right? Creating a numeric representation of text. And then you're going to go ahead and store it in a vector database. So what's a vector database? Why can't we just store it in a traditional database? Well, we can store it in a traditional database like Postgres, MySQL, and that will work perfectly. But the reason why we need a vector database is that a vector database is just like a traditional database. You can query it, but one of the advantages it provides is its ability to do things like similarity search, semantic searches. Basically, if you can retrieve pages or documents based on their similarity to what you're searching for. So let's say that I'm searching for the word. I have a bunch of documents in my vector database, and I'm searching for a given phrase from that database. So it's going to create an embedding of the phrase I want to search for, and it's going to compare it with existing embeddings inside of the vector store, and it's going to return to me the ones that are most close together, right? We can use different techniques like such as cosine similarity that we'll look at. You can use, that's basically how retrieval similarity searches work, right? And don't worry, we'll go more in depth about this later on. So once it gets the document that it needs, it converts the document back into text and then passes it to a LLM, and the LLM is going to go ahead and use that to generate an answer. So basically get a document, break the document into different chunks, creating embeddings, so the embeddings in a vector database. Once the user asks a question, we're going to take the user question, convert it into embeddings, and then use that embedding to search for embedding similar vector embeddings or words or phrases that are going to be similar to what the user asked for. And these are going to be the possible document or the relevant document to what the user asked. So we're going to send those relevant documents to the LLM and tell the LLM, hey, based on this context, which are going to be the list of relevant documents or a relevant document, answer the user question, and you go ahead and specify the user question. So it's going to go ahead and go through all the relevant documents and find the most document that makes more sense in answering the user question, and it's going to use that information to answer the user question. So let's say, for example, I have a CSV file that has the prices of vehicles. I can create chunks and then store those chunks in here. So if I ask, what's the current price of a Tesla Model X? So you're going to convert that into, let's say, current price of a Tesla Model X in 2023. So you're going to go and convert that into word embeddings and use that to search current price of a Tesla Model X in 2023. It's going to find similar embeddings. Once it finds the similar embeddings, it's going to go ahead and return the list of documents that are very similar to what the user asked in terms of semantic. And then finally, the LLM is going to use that and along the user question to generate an answer, because the LLM has its generative capabilities, right? That's the point of retrieval augmented generation. The generation part is for the LLM. The retrieval part is for the vector database. Okay, so that's basically how RAG works on a surface level, on a deeper level rather. So once you have looked at that, now let's go ahead and begin to build our chatbot. So the first thing we're going to go ahead and do is set up a development environment. Okay, so let me just go back and navigate in here. So this is where my current bot is running. So I'm going to go ahead and stop that. And once that's stopped, so stop that. Okay, clear that. And I'm going to go into this window. I'm going to clear here. Okay, so I already have a document, a folder called a RAG chatbot. this is what we're going to be using, and it's an empty folder right now. So just create an empty folder and navigate to that empty folder within your terminal. So once you're in there, what you're going to go ahead and do is create a Python virtual environment. So Python virtual environment help us to keep our project dependencies separate from our Python dependencies, our global Python environment dependencies, right? So we have our dependencies in a small environment, okay, that you can easily manage. So let me just go ahead in here and create a Python virtual environment. Again, the command that I'm going to be using will be different from one operating system to the other operating system. So this command is going to work for guys who are on Linux and on MacBooks. And if you're on Windows, I'll just show you the command just in a bit. For if you're on a Linux and a MacBook, you simply have to type out Python 3 -m and say VNV and then VNV. The second VNV can be anything, but just remember whatever you call the name of the virtual environment. Okay, so whatever name you use here is going to be the name of the folder. The name of the folder that's going to be having a virtual environment. So I'm going to call it VNV. Okay, so just follow along and call it VNV, and that's going to go ahead and create a Python virtual environment. So VNV, just the V is for virtual, and then NV stands for environment. Okay, so some people also call this, people just call this one NV. Okay, anyway, so if I do ls, we can see I have a folder now called VNV, which is what I used right here. Okay, so one on Windows, you simply have to say py and then -m VNV VNV if you're on Windows machine. Okay, that's how you create a virtual environment on Windows. So now the virtual environment is created, we're going to go ahead and activate it. Again, the command is going to be different from guys who are using Windows, but for MacBook and Linux, just use this command. You're going to say source VNV /bin /activate, and that's going to go ahead and activate my virtual environment. And how doing the virtual environment is activated, you can see the name of the virtual environment within parentheses in front of the line in the terminal. You see this line didn't have it, but now this line has it. Okay, so that shows that your virtual environment is activated. For Windows, I think you simply have to do I think it's VNV /, and you're going to say scripts, right? And then / you're going to say activate. Okay, I think that's how it works on Windows. Again, I'm not really sure on this command on Windows because I have not done this in a Windows in a long time, but basically it's along these lines. Okay, so if you have any errors, just Google it. You should get a solution online. Okay, so once the virtual environment is activated, I'm going to go ahead and clear my window. And once my window is cleared, what I'm going to go ahead and do, I'm going to go ahead and I have Visual Studio Code open up right here, and you can see it right here. This is my Visual Studio Code. So now we have the virtual environment created. So what else do we need to do? So we have created the virtual environment. Now let's go ahead and activate our virtual environment, which we've already done. And now let's go ahead and install the libraries that we need. Okay, so we have created a virtual environment. You have it activated. Now you're going to go ahead and install the libraries. Okay, so there are a couple of libraries you're going to go ahead and use. Okay, so I have the libraries just typed out here. So let me just go ahead and type them in so you can go ahead and install all of them. So I'm going to say pip install. You're going to install LangChain. Okay, you're going to go ahead and install PDF. If you know what LangChain is, you can check my channel. I have more videos on LangChain. Okay, so for the beginners, absolute beginners. So I'm also going to install ChromaDB. I'm also going to go ahead and install sentence. Okay, so my bad, sentence underscore. So sorry, send hyphen transformers. Okay, you're going to install sentence transformers. You're also going to go ahead and install Python decouple to help us with virtual environments. You're also going to install OpenAI. You're also going to go ahead and install tick token. And you're also going to go ahead and install lock, just like that. So pip install LangChain, PyPDF, ChromaDB, sentence transformers, Python decouple, OpenAI, tick token, lock. Okay, so I hope that's how it's pronounced. So that's once we have all that, that's all we need to do, and we can just go ahead and press enter right here, and it's going to go ahead and install all the libraries for us. So that's the list of all the libraries we need. I know it's a bit more libraries, but yeah. Okay, so you can just say sentence transformers. Okay, so let me see where I got that wrong. So it says could not find version that satisfies the requirement sentence transformers. Okay, let me think. I think I got that spelling here wrong or something. Okay, so I actually got the spelling of transformers wrong. So it's transformers. Okay, so my bad. So let's go ahead and try to install this one again. So my bad for that typo, is transformers. Okay, I forgot an S there. So this is going to take a bit of time to install all these libraries. Okay, So just be patient. It's going to be depending on how fast your computer is, how good your internet connection is. Okay, so just be patient, and I'll be back recording once this installation gets through. Yeah, so it's almost done right there. So once it's done, then you have all the libraries installed. So let's just wait for a few minutes for this to get done. Okay, so now you have created a virtual environment, you have the virtual environment activated, you have installed all the libraries. So what next? So the next we're going to go ahead and do, we're going to go ahead and simply document, learn how to load documents and split the documents. Again, we mentioned why we split the document because of the limitation of context windows in LLMs. Okay, and so if you want to get a document, you can, I'm going to using the book rich that you can download the book from here. Okay, you can go ahead and download the book from here and just you're going to, that's the book I'm going to be using. So just go ahead and download this book from here and get back to the record. And sorry, download the book and just come back to the video recording. So we're going to use that book, so make sure you have the book. Okay, so now let's check if this is done. So we're going to give this a bit more time to have the things installed. Okay, so that's a lot of libraries, so expect to take a lot of time. Okay, so just be patient, and once it's done, so in the meantime, what I'm going to go ahead and do, I'm going to go back in here, I'm going to create a folder, I'm going to call it documents. Okay, so inside of this document, that's I'm going to go ahead and keep in the books, the book, or the rich.that book, or any other PDF that you have. Feel free to use any other PDF that you have. Okay, just a PDF file. Okay, so let me just go back and get the downloaded file and then bring it in here, and then I'll be back recording. So good, I just have the document loaded in here. You can see I have the book rich.that in there. So good. So and also my installations are done. So once I have them, I'm going to clear the terminal, and let's go ahead. You're going to go ahead and do document loading and splitting, right? Basically to load the document and be able to split the document into different chunks. So I'm going to go back in here. I'm going to create a new folder. I'm going to call it document loading, just like that, and press enter. So I'm going to go ahead and minimize this again. So once I have that done, I'm going to go in here, create a file, and this file is going to be called load. I'm going to call it load underscore end underscore split. Okay, so load and split dot py. Okay, good. So once I have this file created, and you're going to use this to be able to load the document, which is going to be our rich.po.pdf document. You're going to go ahead and split it into chunks to overcome the limitation of the context windows. Okay, of a large language model. So I'm going to say from LangChain. I'm going to go ahead, LangChain dot document underscore loaders. I'm going to go ahead and import py pdf. Okay, that's py py. Okay, let me get the spelling right. Py pdf loader, just like that. So I'm going to import those files. Okay, so it looks like it didn't pick up my, okay, it picked it up, so good. So I'm going to say from, it was lagging a bit, so I'm going to say again, we say from LangChain dot embedding. So embedding, so I'm going to go ahead and import something. I'm going to go ahead and import dot embeddings. I'm going to say dot transformers, right? Sentence transformers. So the sentence transformer is going to go ahead and help us to be able to create the embeddings. Okay, so I'm going to go ahead and import sentence transformers embeddings. I'm also going to say from LangChain dot vector store. I'm going to go ahead and import Chroma. Okay, so we talk about Chroma vector stores, which basically is just a database, but now it stores what embeddings. Okay, so good. So now that we have all that imported, now let's use a PDF loader to be able to load in a PDF document. So we need the path of the document, and I'm going to call this path, or you can call it file path if you want. So I'm going to say file underscore path, and this is going to be equals to a string right here. I'm going to go ahead and simply say dot backslash, and I'm going to call this one is going to be in a file called, we're going to go one direct, because we're in here, we're going to go one directory back. You're going to go ahead and go into document. So documents, I'm going to do a / is called rich.that. So I'm going to say rich. Let me just go ahead and try to get a name from here. I'm going to say rename, and I'm going to go ahead and select all, copy that, and just go ahead and paste it right here. Okay, so paste it right here. So once I have that pasted right there, I'm now going to go ahead and simply create okay, we get create loader, and I'm going to simply say loader is going to be equals to py pdf loader. And I'm going to go ahead and simply pass in my pdf document. So I mean, this is going to be file path right here. So you basically pass in the file path that you want to pass. You can also go ahead and say file path, and that's right. Okay, so we're going to pass in the file path of the PDF that you want to load, which is going to be this part right here. So that's this is going to go ahead and load the document. Once the document is loaded, you're going to go ahead and get all the individual pages. You're going to simply split document. You're going to go ahead and simply say you're going to turn to us pages. We call them pages. So you can say loader, right? This the object of the PyPDF loader class. You're going to simply say loader.load underscore and load and split right here, just like that. So that's all we need to do to load and split the document. So once we have it, you can go ahead and simply say print pages, or you can simply say print the length of pages to see how many pages we have. So that's all we need to do. So I'm going to go back in here, and I'm going to go ahead and change directory into my document loader, and I'm going to go in here and simply say Python 3 load and split, and then run that file. Okay, so once I have that file running, this is going to go ahead and print for me the number of pages that we got after loading and splitting the document. So this is going to take a bit of time, and once that's done, it should now let us know how many splits we got from it. So we got 227 splits or pages from it. Okay, so good. So once we have that done, I'm going to go down here, and I'm also going to go ahead now create embedding function. So I'm going to go ahead and say I can now delete this print statement, so you don't need it anymore. I can just go in here and clear a couple more pages, and then back in here. So I'm going to simply say it's going to be embedding functions right here. So I'm going to simply say embedding function and give it any name you want. So embedding, let's call it embedding underscore function. Function is going to be equal to, going to use the sentence transformer embeddings, and in you're going to go ahead and pass in the model underscore the model name that you want. The model name is going to be all hyphen mini lm hyphen l6 and then hyphen version 2. So that's all we want to do. So that's the model name that you want to use. So all hyphen mini lm hyphen l6 hyphen v. So make sure that you watch out for the camel case, sorry, for the upper cases and the lower cases all in here. Make sure you watch out for that to get the model name right. So it's going to create for us a function that you're going to use to embedding. So in here, you can decide to use different embedding functions that you want. You can decide to use the one provided by OpenAI if you want to, but I'm going to be using this free one because you don't have to pay for it, right? But if you're using the OpenAI embeddings, then you have to go ahead and pay for it, and you have to have an API token that will create later on as we go along. So now once we have that done, I'm going to go ahead and simply create a vector store that's going to go ahead and store this embedding. So I'm going to go ahead and simply say create a vector store, just like that. So I'm going to go ahead and simply say vector db vector database is going to be equals to, we're going to use Chroma to create a database, vector database. So we're going to say Chroma, and we say dot from underscore documents, and I'm going to go in here and pass in all that we need. So let me just make sure that this is right. Okay, so this is actually Chroma, so this is actually a capital C right there. Okay, so we're going to say vector database is going to be equals to, it looks like okay, this is right. So from vectors, from LangChain.vector stores, I'm going to import Chroma. So Chroma, just like that. Yeah. Okay, so once I have that, I'm going to go down in here, and I'm going to simply say documents, beside documents, and it'll be equals to, and I'm going to go ahead and say documents are going to be our pages. You're going to go ahead and also say the embedding function, embedding, basically embedding is going to be equals to our embedding function that we have created above. So embedding function, so this is actually embedding. Okay, so once we have that done, I'm also going to go ahead and pass in the persistent directory. The persistent directory help us to make sure that this gets saved or persistently, okay, on our device. So we're going to say directory. So persistent directory is going to be equals to, and you can specify a part of the persistent directory that you want. So I want to go ahead and save it in the root directory of our project. So I'm going to say vector underscore db. So we're going to have a folder in the root right here called vector db, and in here you're going to go ahead and also specify the collection name. So collection underscore name, and you're going to say the collection name is going to be rich underscore dad underscore poor dad. Again, if you don't know how why we are creating a collection and what is persistent directory is just a folder in which we are going to have the vector database stored in persistently. It's going to be persist. It's going to have a collection name. And if you know about all this, I have an article written on all this, and I'm going to leave the link to the in the description of the video on where you can find the article about this. Okay, so I won't talk much about this. You can find out the video where I explain everything in detail. If you are new to vector databases, especially ChromaDB, you can read about it from there. Okay, so once that you have that, I'm going to go ahead and simply make persistent, just like that. I'm going to simply say vector db dot persistent, just like that, and then call that. Okay, that's all I want to do, and I'm going to go ahead and save that code right there. So now let's go ahead and run this code. So this is going to go ahead and load the document, split document into different pages, smaller chunks to overcome the difficulty of context windows, create embeddings of each of those little chunks, and then store them in a vector database and make sure the vector database is going to be persistent. So once I have that, I'm going to clear the terminal and then simply run the code again. So this is going to be take a bit of time because it has to create load the document, create embedding. So it depends on how fast your computer is and how fast your processing is. So let's give a bit of time for this to get through. And then once this is done, I'll be back recording. Yeah, guys, so you can see now that's done, and you have the vector database created. And so if you go back in, you should see a folder called vector_db, which is the folder consisting of our Chroma vector store. So good. So now that you have this vector store, now our models, we can run queries against it to find out the relevant piece of document to be able to use to answer the user question. So we have basically 227 documents. So basically each the whole book is broken down into smaller chunks of 227, and there are embeddings created for each of those chunks, right? So if you ask a question, you're going to take your question, create embeddings of it, and use that embedding to check against existing embeddings in the database and see of all the documents which one has more similarity to what you're asking in terms of semantic similarity and vector embedding similarities, right? So that's basically how retrieval works, right, to retrieve the good document. So good. So now that you have done that, you have loaded the document, you have basically load the document, split it into chunks, and then basically create embeddings of each, and then finally store that in a database. So we have created embeddings, and basically embeddings are just chunks of those documents that are stored in a numerical representation, right? So we started off with the original documents, right, with different pages. We broke it down into smaller chunks, and then create embeddings of each, right? A vector embeddings of each, and then store those vector embeddings in a database. So that's all we have done till now, right? Good. And the database that we have created is called right here is called vector DB, which is our Chroma vector database. Good. So now that you have done that, now you have the vector stored. How are we able to retrieve information from those queries? So let me just go back in here. I think I have a document which explains this. If I go back, back, let me see if I can find that document on rag piece. Yeah, this document right here, this slide right here. So you can see we have the document. We have split the document into chunks. We have created embeddings of each of those chunks, and we store that in a vector store. That's what we have done so far, right? So now, how are we able to retrieve the relevant document to answer a given user question? So that's what we're going to go ahead and do right now. And there are different techniques of achieving this. So let me just go back to where we were. Okay, so basically document retrieval techniques that are used to retrieve the relevant document that can be used to answer the user question. So this basically, one of the approaches is simply using a normal semantic similarity check or similarity search based on word similarities, right? So there are different techniques to find word similarities, basically comparing the vector embeddings with another vector embeddings to find out the similarity between the two vector embeddings. So we have a bunch of vector embeddings right now in our vector store. So if a user asks a question, we're going to take the user question and convert it into vector embeddings, and then check. We have this question that we have converted into vector embeddings. How similar is it to the vector embeddings that we have in our vector store? And that you can be able to search that. There are different techniques of using to find such similarity between the two vector embeddings. One of them is cosine similarity. And I got this image from online called Simply Intelligent, NGAT. Okay, so that's the resource where I got the image from, so credit to them. So basically, that's how you can use cosine similarity to search to perform semantic similarity between two words or more. Okay, so I'm not going to go into depth about cosine similarities and other approaches used to perform semantic similarity. Just to mention it, in case you want to read about it, feel free to go ahead and read about it. Okay, so the first thing I want us to do is simply implement a simple semantic search. So how does that work, and how are we able to use that to answer the user question? So let's go ahead and look at the basics similarity semantic search. So I'm just going to go back. Let me go back one directory back, sorry, one slide back, and I'm going to go back in here, and I'm going to go ahead and create a folder, and this folder I'm going to call it retrieval underscore techniques. Okay, retrieval techniques, and I'm going to go in here. I'm going to call this one, going to be basic underscore semantic underscore search dot py. That's it. So in here I'm going to go ahead and import basically write the code to do perform a basic semantic search. I'm going to say from okay, let me get that spelling right. So from LangChain from LangChain dot embeddings dot sentence transformer, we're going to go ahead and import the sentence transformer embeddings we imported in the last document. Also going to go ahead and say from LangChain dot vector stores, I'm going to import chroma, just like that. Okay, I'm going to import chroma, and I'm going to have a bunch of documents that I'm going to use to test again. So this is just a bunch of strings that I'm going to use just for you guys to understand context. Instead of me using the vector that I just created that consists a lot of documents, I'm going to create a simple text that has a couple of about 5 sentences, and I'm going to treat each of those sentences as a document and then create embeddings of each, so that it's much easier for you guys to understand than me having to use this other one vector that you just created that consists of 227 documents. That can be a bit tricky to understand. So, okay. So I'm going to go ahead and grab the text, paste it right here, and I'll be back recording. Okay, guys, so you can see I have some documents, some text pasted right here, right? We have a list of text, first text, second text. It's just about describing what Python is, right? Python being used in data science, machine learning, different cross platforms, Python running on different systems. Just the simple documentation, basically a simple introduction to explanation of what Python programming language is. Okay, so I just created this from ChatGPT, and then I split the sentence into multiple pieces, and then simply place each bit to have 4 different sentences within our list right here. So we're going to list each of these as a document, as our document, and we can also provide the source document metadata. Okay, so each document you're going to provide in the source, which is going to be document 1. So this is going to be document 1. It's going to have a metadata of document 1, page 1, and this is going to be document 2, source of document 2, page 2. This one page its source is going to be document 3, page 3. This is going to be its source, going to be document 4, page 4. Right, so that's basically the metadata. So metadata is a data about data, right? So that's what metadata basically is. So now let's go ahead and create the embedding function we're going to be using. So I'm going to copy this from right here and simply bring it right here. Okay, good, and then save that. And I'm going to go ahead and create the vector database. So I'm going to go down here. I'm going to say vector underscore db is going to be equals to chroma dot this is going to be chroma dot from. You're going to say from text right here, and then pass in the function. So you're going to say text text is going to be equals to the list of text that we have right there. I'm also going to go ahead and pass in the embeddings. So embedding is going to be equals to our embedding function that we have. So going to go ahead and pass in the metadata. So metadata. So metadata is going to be equals to metadata that you have. Okay, so that's all we need to create a simple vector database. In this case, this vector database is not going to be persistent. Okay, so it's just going to be a temporary. Okay, so now once we have that done, I'm going to go down here and I'm going to simply say let's ask it a question. So I'm going to say we're going to store the response of the answer to this question. We're going to store it in a variable called response. What I'm going to simply do, I'm going to say vector database dot similarity. Okay, let me get that spelling right. So similarity underscore search, and then finally we pass in the question that we want to ask. So I'm going to say query, and the query is going to be equals to, and you can pass in a question. So I'm going to simply say, tell me about programming. Tell me about a programming language used for data science. Okay, so tell me about the programming language for data science. And I want to specify K as 2. So what's K? K basically is a number of relevant documents that correspond to answering, or that have content that can be used to answer this question. So I only want 2 relevant documents back, right? So if there are 10 documents that can be used to answer this specific question, I only want 2 of those documents back, and that's what K specifies. Okay, so I hope that's clear. So let me just minimize this again. So that's basically what K does. Okay, so that's basically it. So once we have that, now I'm going to go ahead and simply print the response onto the screen. So what you can see, one of the advantages of vector stores is that we have this functionality to be able to perform things like similarity searches, while as in a traditional database such as Postgres, MySQL, we do not have that capability, right? So that's one of the reasons why we're using a vector store instead of a traditional Postgres database, right, or MySQL database. So I hope that makes sense. So let me just go back in here, change directory back, and then once I'm in here, I'm going to change directory into my retrieval techniques folder. And once I'm in there, I can do an ls. You can see I have one file in there, so I'm going to run that file. I'm going to say basic, and then simply run that file. So this file should now go ahead and try to answer the question. Tell me about a programming language used for data science. So it should retrieve all the documents that are relevant to answering this question, and we specify K as 2, so it's going to return to us only 2 of those documents. Even if you got 1,000, you only want 2 back. Okay, so I got an error right here. So I got an error. So this is actually supposed to be from text. So my bad. So let me just make sure that I don't have any more errors. Embeddings and then metadata right there. Okay, so clear this and then simply run that code again. My computer seems to be lagging because I am recording, so bear with me on that one. So basically, it should return to us 2 documents that can be used to answer the question that we ask, and those 2 documents are called relevant documents, right? The relevant document that can be used to answer the question. So let's see what we get back. So it returned to us a response, and you can see we have 2 documents back right here. So you can see this is the first document from here to here, the first document, and this one right here is a second document, right? So the first document, what does it say? So it returns to us the content. So you can say this is a general purpose language suitable for web development, analysis, machine learning, Python, blah blah. You can see mention also Python. Python offers an extensive assembly libraries. You can see you got that. So it particularly gained popularity in data science and all that. So it mentioned a language that can be used in data science. In this case, Python is a language that can be used in data science. So you can see it provides us with documents that are relevant to answering the question of tell me a programming language that can be used in data science, right? So now that you have this document, you can simply pass this document into an LLM like a ChatGPT, and it will provide you with actually a well-detailed answer basing of this information, right? So that's basically how retrieval similarity searches work. Good. So you can also do you can print out each page and then print out the page content if that's what you want to do. That's also possible. Just for the sake of time, I'm not going to do that. Okay, so now that we have looked at similarity search, and are there any other document search techniques that you can use? And the simple answer is yes, there are a couple of them you can use. We also have one called maximum marginal relevance. So this does not only give you the right context to work with, but also ensures diversity. Okay, what does that mean, diversity? Let's say we have a lot of documents, right? We can assume this as our documents. So we ask a question, and these 2 documents, right, provide us with the relevant documents or the relevant information that you can use to answer the question, right? But now they are basically similar in what they provide. So with MMR, right, marginal maximum marginal relevance, we can now not only, instead of returning just these 2 documents, we pick diversity, right? Okay, these documents basically mean the same thing. Let's also select another document that has that is relevant to answering this question, but that has a different context or different information. So in this, instead of saying Python is a programming language, you need to also say Python is a programming language that is used in cross platform like Windows and Linux. What relevant MMR is going to do is that it's going to tell us, okay, this document is gonna be talking about Python being a programming language, and this one is, instead of talking about Python is a programming language that can be used in multiple cross platforms, it's going to go ahead and maybe say Python is used in data science, is used in data analytics, is used in machine learning. That it includes diversity, and that's what we achieve with the help of marginal maximum marginal relevance, so MMR. So let's go ahead and try to implement how MMR works. So I'm going to go back in here and I'm going to find a file. I'm going to go ahead and simply create a file rather. I'm going to call this file, I'm going to call it mmr.py. Okay, good. So we're going to use this mmr.py file to be able to create to implement MMR. So I'm going to basically copy everything that we have from the basic semantic search, paste it right here. And what you're going to go ahead and do, the only part you're going to change is right here. So instead of saying similarity search, which you're going to simply say maximum underscore marginal underscore relevance, just like that, underscore search. That's it. So maximum marginal relevance search. So that's basically what MMR does. So it's going to return to us the same a language that is going to be a language that is used for data science, but now we should expect more diversity in its response in terms of the relevant documents compared to using similarity search. So let me just go ahead and run this. I'm going to run the MMR file, and then let's run. And now we should get back more diverse documents instead of just, you can see all these pointing about gain popularity in data science, suitable language used for web development. It basically mention the uses of Python, right? These are used in data science, machine learning, and other stuff like that. But this is also saying suitable for web development, data science. So you can see it's basically the same information. Now with MMR, let's see the response we get back. So it is a general purpose language, so you can see it's very similar to the first one. Let's see what the second document measures. It has gained popularity in data science, so it also basically mentions the same thing. So let's see if we have only two documents, right? You specify K as only two. Yeah, so in this case, MMR didn't work much enough, but let's try to let's say that in some case you get really good output out of it. So in this case, MMR didn't work much enough, but basically it improves relevance. Okay, increases the relevance of the diversity within the documents. So that's basically what MR does. In this case, you can say machine learning used to ease of availability, powerful libraries. So you can see it's the same thing that mission document 4 and document 2. And it's also mission document 4 and also document 2. So you can see in this case, the MR didn't really work really well, but in some cases it works really fine. So again, if you run this another time, because it's machine learning, sometimes the results can be different, right? So I ran this a couple of times on my end, and the results were much different, and was different from what we got from using a similarity search. But in this case, you get back almost the same response as similarity search, right? Yeah, so we can improve more on this, and you can get better response out of this. So yeah, that's basically, you can work around it. Okay, so in this case, it didn't give us much of a response. So one thing we also specify in here, let's try to specify this and see if it is going to go ahead and change the amount of response we get back. So you can also go ahead and specify fetch underscore k. So fetch k basically fetch the number of diverse documents that you want. So let's say fetch k is going to be 3. Okay, so let's go back in here and let's run this again, and let's see what we get back. Yeah, so even in setting k as being 3, we didn't get much of a difference, but don't worry, that it sometimes gives you really good diversity in terms of the text. Okay, so now that's basically how you can work with maximum marginal relevance, or MMR, okay, for retrieval. Okay, so now let's move on to another technique that you can use, and this technique is called contextual compression, compression retriever. So this is another way you can use to retrieve relevance documents from our list of documents from our vector database. So basically, this one compresses the bunch of context, right, into two or three sentences that contain the exact information that you're looking for, and then passes this information into our LLM. So basically, this does the compression with the help of a large language model. So it picks a bunch of documents that are relevant in answering your question, and then tries to compress these documents down so the documents contain only the relevant information that you want. So for example, you're looking for a price of a vehicle, right? So in the first document says, hey, the price of the vehicle is this amount, okay? And another document says the price of the vehicle on this date is this amount. So basically, they're all talking about the same amount, right? Let's say the amounts are similar. So basically, contextual compression will compress that information just to give you the price of the vehicle instead of mentioning the repeated information. So it does this using the help of LLM. So one of the downside of this is that you have to make a more LLM calls, but at the end of the day, it's worth it because it compresses the information, and it depends on the context under which you are using this. Okay, so yeah, so to work with this, one of the things you need to do to work with this is that you need to have to get an open AI key, an open API key. So go to openai.com and then get an API key from the official website. So I'm not going to go ahead and show you how to do this. It's quite straightforward. Just go to openai.com on Google. I'll leave the link to that in the description of the video. So once you go there, create an account and then go into your account page and go ahead and get an API key. I don't want to show you this because it might change from time to time because their website can be updated anytime. Okay, so it doesn't make much of a difference that I show you or not. It's quite easy. You can do this on your own. Okay, so again, I'm going to leave a link to that in the description. You can just click on that link. It's going to direct you to that page where you can get your API key. So once I assume that you have your API key, you can come back in here, create a file, and I'm going to call this file .env. So sorry, dot and then env. So make sure it's dot and then env. Okay, and you're going to go ahead and say open AI underscore API underscore key. It's going to be equals to, and then finally you're going to go ahead and paste in your API key. So it's going to be something like this, and then some gibberish stuff follows afterwards. So you're going to go ahead and paste your open API key in here. Okay, so this is going to be called OpenAI equals to, and then paste in your open API key that you got from the OpenAI website. Okay, so let me just go in here and get my API key and then put it in here because I don't want you guys to have access to it. So I want to put it in and then close this file and then back recording. Okay, so just give me a second and let me do that and I'll be right back. Okay guys, so I've just done that and I'm back recording. So let me just go ahead and show you how we can use the contextual compression retriever. So I'm going to go ahead and in here our retrieval techniques, pass in a file. I'm going to call it contextual underscore compression underscore retriever dot py. Okay, so in here I'm going to go ahead and write in the code for it. So let's go. The first thing we need to do is let me just go ahead and get the basic code from here that we have so far. So I'm going to go ahead and get this right here. We need all of this. So I'm going to go ahead and close all these windows, all these files. We don't need them. So paste that in here. So basically we just import the code to create for us, set up for us a vector store. Okay, so once I have that, I'm going to go ahead and import a couple of things. So I'm going to say from LangChain, I'm going to go ahead and .llms, so LangChain.llms. I'm going to go ahead and import OpenAI. Sorry, this is going to be OpenAI with a capital O. So OpenAI, just like that. I'm also going to go ahead and import, okay, this is an OpenAI is lowercase, so OpenAI. I'm also going to go ahead and import a couple more. So let's say from LangChain.retrievers, I'm going to go ahead and import contextual compression retriever. Again, I think this is capital A, capital O, okay, because it's a class, right? Yeah, so that's it. And I'm going to go ahead and import two more things. I'm going to say from LangChain dot retrievers dot document compressions. So document compressors. I'm going to go ahead and import LLM chain extractors. I'm also going to go ahead and say from decouple, I'm going to import config. So it's going to help us to read our environment variable. Okay, basically our open API key that we kept in this env file. Okay, so once we have all that done, this is going to go ahead and create for us the vector store with the information that we have. So I'm going to go ahead and create an LLM. So I'm going to go ahead and say LLM is going to be equals to, I'm going to use the OpenAI. Okay, so OpenAI LLM. So I think I got the name even here up wrong. So it's going to be OpenAI, just like that. And in here, I'm going to go ahead and pass in a couple of things. So I'm going to pass in the temperature. And I'm going to leave the temperature to be 0. I'm going to pass in the open underscore AI underscore open AI underscore API underscore key. And this is going to be equals to config. And I'm going to go ahead and pass. So in here, I'm going to go ahead and say basically open AI. So open AI underscore API underscore key. And this is the name that we have inside of this virtual environment. Okay, so we said open API key equals to, and then you paste it in your API key. So if you use something different, then you have to use the same name right here. Okay, so that's going to go ahead and create for us an OpenAI LLM, and I'm going to go ahead and say compressor. I'm going to create a compressor. So compressor compressor is going to be equals to LangChain extractor. You're going to go ahead and say dot from underscore LLM. You're going to go ahead and pass in our LLM, which is going to be LLM that we just created above. Okay. So once we have that, I'm also going to say compressor. I'm going to say compression underscore retriever is going to be equals to, I'm going to say contextual compression retriever, and I'm going to say the base underscore compression. Compressor is going to be equals to the compressor we just created above, compressor. I'm also going to say the base underscore base retriever, and it's going to be equals to our vector database that we just created. Our vector database, I'm going to say dot as underscore retriever, just like that, and that's all we need to do. So I just say this, you're saying dot as retriever to make this a retriever. You're passing our base compressor as a LLM chain extractor dot from LLM, and you're passing our LLM, which is this open API LLM. Okay, so once we have that done, we are good to go. So now it's going to go down here, and I'm going to say compressed. I'm going to say compressed underscore docs is going to be equals to, I'm going to say compression retriever dot get underscore relevant documents. I'm going to go ahead and pass in, I'm going to ask the question. So what is the areas in which Python is used? Okay, that's it. And I'm going to go ahead and simply print the response of the compressed document right here. So compressed documents, compressed docs. So that's basically it. So that's all we need to do. So we have basically the vector store created. We created an LLM, and then from there, okay, got this wrong right here. Created an LLM, and then from there we created a compressor, and then we created a compressor retriever, a contextual compression retriever, which basically does the compression and retrieving. And then finally, we pass in the base compressor as a compressor created above here, the retriever as vector space dot retriever, and then we pass in this, and then finally print out the final document. So that's all we need to do. So once I have that, I'm going to go back in here and then run the code. Okay, so once I'm in here, I'm going to go ahead and simply run the code. I'm going to simply say Python 3, and then finally say, okay, let me just make sure I'm in the right directory. Yeah, so I'm going to say Python 3, and I'm going to say contextual retriever, and then run that. So that's going to go ahead and do the compression and retrieval for us using the help of an LLM. Okay, so it's going to take a bit of time because we have to make multiple calls to the OpenAI APIs to get the compressed data, and then finally you're going to get a return of that compressed data. So let's give it a bit of time, and it depends on how fast your computer speed is, right, based on the internet. So let's give it a bit of time. Sometimes it is slow, also depending on the traffic of OpenAI. So let's see. I got an error right here. So okay, temperature. The spelling of temperature. Okay, I got that wrong. So it's gonna be temperature. Okay, so my bad for that. So let me just go ahead and clear this and then run this one more time. Okay, so now let's see if this works. So you're gonna create a vector store, creating the LLM model, creating the compressor retriever, get the relevant document. Okay. So we're getting some warnings here. Just ignore these warnings. Let's see what we get. So you can see, just ignore the warnings, and you can see at the end of the time we get back the document. Okay, so it mentioned document 2 and document 4. Okay, so document 2 and document 4, and you can see also these are the same documents that we got back from the other retrieval methods. So in this case, we just have a bunch of few sentences. So actually had document 2, document 4, and document 3. So it gives to us the documents that answer that question. Document 1, document 2, document 3. So it answers 3 different documents that can be used to answer the question. So that's basically how retrieval, we can use contextual compression to be able to perform that. Okay, so yeah, that's it on contextual compression. In this case, it's a very simple example, so you might really not see that much of a difference. But whenever using a larger set of data, which is like the file that you have, you're able to see the difference in that. Okay, so that's basically how compression retrieval works. Good. So once we have that, have that out of the way. Is there any other technique? Yeah, there's one more technique called self query. So how does self query retrieval work? Okay, so it's used when the question asks all the text we want to search the vector store against is just not to deal with semantic but also metadata about the semantics. Okay, let me explain this in a simpler way for you to understand. Let's say that I want to ask, okay, in document 4, what was mentioned about Python? So I want something mentioned about Python, but I want it specifically from document 4. Document 4 is a metadata. So you can also specify, I want it from page 4. So from page 4, what was mentioned about Python? Or from page 5 and from page 5 to page 6, what was mentioned about Python? So it's not only going to search for what was mentioned about Python in a document, but also going to take into account the different pages that you specified. And that's what self-query comes into play. So for example, let me show you how we can perform self-query using Python. So self-query, let's just create a file right here, and I'm going to call this file self_query.py. Okay, so now that I have that file created, what I'm simply going to do, I'm going to go inside of the context. Okay, I'm just going to go in here, copy this and paste it in here. Good. So once we have that, I'm going to delete a couple of things. I'm just going to leave the part where I create a vector. I'm also going to go in here and delete this. I don't need this. Okay, so in here, what I'm going to do instead, I'm going to simply say dot self query. I'm going to go ahead and import the self query. So let me see self query. Okay, self query.base. I'm going to go ahead and import self query retriever there. Good. So once I have that, let's go ahead and try to use that. So I'm also going to delete this for right here. I don't need this. So instead, I'm going to go ahead and delete this, and I'm going to say from chains. I'm going to from chains. Let me say dot query constructor dot base. I'm going to go ahead and import the attribute. The attribute. Okay, I'm not getting a helper here, so I'm going to say attribute info, just like that. Okay. So yeah, so from LangChain.chains.query constructor.base, I'm going to go ahead and import attribute info. Okay, so that's all I need. So once I have this done, I can simply go ahead and use it to create a self query. Okay, so once I have that done, I'm going to go ahead and grab some code from my GitHub page just to make things much faster. So I'm going to go into Retrieval, and then I'm going to go into self query. I'm going to go ahead and get the code for self query right here. So I'm going to get this piece right here. This one's right here. I'm going to go ahead and simply copy this and simply bring it in here just to save on time, because I don't want to take so much time with this. Okay, so I've already taken a lot of time already. So good. So that's all I want there. So basically, we've just provided a description of each of these attributes. So you can see each of these metadata. So you have the source, and what does the source do? The source provides the documents number, right? There are 4 main documents: document 1, document 2, document 3, document 4. Right, you provide a description of the metadata. That's what it does. That's what the attribute info does. You also have the page, which provides information about the page. These are the page numbers, details of the page from the details of Python, and then that's like that. Then you have also created the document content description. So info about Python programming language, and then you created an OpenAI LLM. And then finally, go ahead and create a self retrieval query. From LLM, we pass in our LLM, pass in our vector store, which we have up here. We pass in our document contents, right? Which is the document content is this one right here. And we pass in the meta information, which is this one right here, the descriptions. And we pass in verbose equals true, so you can see what's going on in the background. And basically, ask the question: what was mentioned in the 4th document about Python? So I mentioned specifically I want information from the 4th document. So what is said in the 4th document? Python is gaining popularity in data science, machine learning due to its ease of use and accessibility. You can see it mentioned that right here. So let me just go in here, back into my terminal, clear this, and let me make sure that I run this one. So Python 3, and this is going to be self query and then .py. So run that, and let's see what we get back. Okay. So again, all the code I copied just from now, the code is available on GitHub. The link, you can find the link in the description of the video. Okay, so I have all that information right there you can access and use. So it's going to take a bit of time, and once it's done, we should get back a self-queried relevant document. Yeah, so you can see you're getting a warning. Just ignore those warnings for now. Yes, so you can see, go to the document back. The document says it was particularly mentioned again, particularly gain popularity, and you can see it returned to us specifically document 4. just document 4. It didn't return in a document apart from document 4, right? So good. So it only returns information specifically from document 4. That's what self query does. Okay, good. So if you're having a book and you want to say you want to query something about page 50 of the book specifically, then you'll be going for self query. So in this case, we have the book rich that poor dad. If you want to find some information about page 40 specifically, then you'll be using something like self query, right? A self query retriever to do that, because you can pass in metadata as well. Okay, yeah. So guys, that's all for this. That's all for this video. We have gone over the basics of document loading, basically basics of RAG, right? So we have gone over document rolling, loading, splitting into chunks, creating embeddings, storing those embeddings in the vector store. Basically, let me just go back into this document so I can show you right here what you have done so far. Yeah, so I think I have it right here. It's a bit back. Yeah, I think it's this one right here. Okay, good. This is the document I want. Okay. Yeah, this is the diagram right here. So you have begun the document, you have loaded the document, you have split into chunks, you have created embeddings and stored that in a embedding vector store, right? And once you get a question, you're able to retrieve the relevant documents. So now once you have the relevant documents, how do we use that to answer the user's question? Okay, and that's what we're going to be covering in the next video. In the next video, I'm going to show you how to use the retrieve documents to be able to answer the user's question, right? So that's all. And there are different techniques of doing that. So in the next video, we'll cover the different techniques of doing that, and then we'll begin to build the bot finally. Okay, so this I'm just showing you the basics of these techniques that we'll use at the end to build the bot. Okay, so guys, thank you for watching so much. If you enjoyed this video, don't forget to like, to share, to subscribe to the YouTube channel if you haven't already, and to stay updated on different videos on Python, machine learning, AI, and cool stuff. Okay, so stay subscribed and see you in the next one. Keep safe.